नमस्ते, गुड मॉर्निंग, सबको स्वागत है। वेलकम टू करंट स्कैम वर्ल्ड। इस वीडियो में केमिस्ट्री सॉल्यूशन colligative प्रॉपर्टीज चैप्टर वाइज फार्मूला रिमेंबर करने के लिए ये क्विज ज़रूरत है। प्लीज़ टेक दिस क्विज so that you will remember the formula in the exam time and also बहुत यूज़फुल है फॉर कॉम्पिटिटिव एग्जाम्स के लिए। ओके, लेट अस सी द क्वेश्चन। ठीक है, let us see the first formula in solution chapter. We'll see chapter wise so that you can easily remember the formula. You will recollect when you write the exam. What is the formula for ppm, parts per million, and its unit in different units that are expressed in microgram per gram. Parts per million is equal to WB by WA plus WB into 10 power 6 microgram per gram. Micro means 1 in million, that is the meaning. How many? For example, hardness of water is measured in terms of parts per million. Okay, so weight of calcium ion divided by weight of the solution into 10 power 6 microgram per gram. So weight of solute divided by weight of solution into 10 power 6 microgram per gram. Now write the formula for parts per million in microgram per ml instead of gram ml. So in this, we will weight of solute divided by volume of the solution. Instead of weight of solution, you write volume of solution into 10 power 6 microgram per ml, its unit. Next, what is the formula of ppm in micromolar per ml? In chemistry, we always use moles. So how it is found out? By using this formula. What is the formula? Parts per million equal to number of moles of solute instead of weight of solute, number of moles of solute divided by in the volume of the solution into 10 power 6 micromole per ml. Next formula, next question. Give the relation between depression of freezing point and molality. What is the relation between depression of freezing point and molality? As you know, the depression of freezing point is delTf is directly proportional to molality of the solution, molality, and delTf equal to Kf. It is the proportionality constant. The depression of freezing point depends on the molality of the solution, the concentration of the solution. As concentration increases, the depression of freezing point also increases. So it is the molar depression constant. When molality is equal to 1, delTf equal to molar depression constant. Next, give the relation between elevation of boiling point and molality. This is same as this. This is elevation of boiling point is equal to Kb into m, where Kb is proportionality constant, that is called molar elevation constant. Next, what is the formula? This is for solutes undergoing association or dissociation. These are the formulae used for solutes do not undergo dissociation or association. For solutes undergoing association or dissociation, the below formula is used, that is delta TB, elevation of boiling point, increasing boiling point, is equal to I, here you put I, kbm, where I equal to Van Gogh factor. Similarly, for depression of freezing point, equal to I kfm. Now, in this formula, m is molality. How molality is calculated? So, in the next, what is the formula of molality in several terms, in solvent weight in kg? So, molality is equal to, as we have already studied, number of moles dissolved in 1 kg of solvent, that is NB, number of moles of solute, divided by weight of solvent in 1 kg. Therefore, NB by WA. So, this formula is for weight of solvent in kg. Okay. Now, what is the formula used for calculation of molality in solvent mass in gram instead of kilogram? Usually in exams it is given in grams, not in kilograms. So, let us first NB. What is NB? NB equal to W, weight by molecular mass. Let us substitute here, and weight of solvent WA. So, WB by MB into weight of solvent in kg. So, this is in kg. This formula is used when the solvent weight is given in kg. This is the formula used when mass of the solvent, weight of the solvent in gram. Okay, so for example, WA gram equal to WA into 10 power 3. How gram is converted into kg? WA into 10 power minus 3 kg. Let us put WA into 10 power minus 3. Okay, so it will minus 3 will go up to numerator, that is 10 power plus 3, 1000. Therefore, M equal to 1000 WB by MA, MB, WA. This is the molality formula when the weight of the solvent is given in grams. Okay, next, what is the formula for Raoults law for non-volatile solute? There are two formula for Raoults law, one for volatile solute and for non-volatile solute. Give the formula for non-volatile solute. This is the relative lowering of vapor pressure. What is relative lowering of vapor pressure? P0 A is the vapor pressure of pure solvent minus Vp. P is the vapor pressure of the solution after adding solute to it, divided by vapor pressure of the pure solvent. Okay. This is lowering of vapor pressure. So, the whole term is called relative lowering of vapor pressure is equal to mole fraction of solute equal to, what is XB? Mole fraction of solute is equal to NB by total number of moles. Now, let us see what is the formula for Raoults law for volatile solute. This is for non-volatile solute, which decreases the vapor pressure. To obtain this, Dalton's law of partial pressure expression is used here. This is nothing but Dalton's law of partial pressure. According to Dalton's law of partial pressure is equal to PA plus PB. That is, it is equal to the total pressure is equal to sum of the individual pressures of the various components present in the solution. This is the partial pressure of A, individual pressure of A, this is the individual pressure of B. How individual pressures are calculated? Individual pressures are calculated. This is the vapor pressure of the pure solvent, their mole in times their mole fraction. So if its mole fraction is higher, then this component will be higher. This part will be dominating. Okay, so E naught vapor pressure of pure component B, both are volatile. Here both the solute and the solvent are volatile. Okay, so these are the individual vapor pressures. They depends upon the concentration of A in it. Okay, let us see the next formula. What is the formula for dilution? This is so often used in practicals or in industry or in at home also. So how the molarity changes upon dilution. So this is the formula N1V1 equal to N2V2, or if the concentration is given in molarity, this M1V1 equal to M2V2 is used. For example, you have 100 ml volume, okay, and you have N1 normality 0.1, let us say. Now you want to you add 50 ml. You need 150 ml, so you add 150 ml. So what is the normality? So N1 you know 0.1, V1 volume 100, so 150 ml. So what will be the normality? This is the formula used for calculation. Okay, now let us see the 12th question. Give the formula for osmotic pressure. This is very important. So often asked in all exams. For PD is equal to nRT for ideal gas. For solution pi V equal to nRT formula is used, where pi is called osmotic pressure. Let us bring N by V here. So pi equal to N by V RT, where N by V is nothing but is equal to concentration of the solute. N by V is the number of moles of the solute divided by volume of the solution into RT. So this is the formula used to calculate the osmotic pressure of the solution. Now, what is the formula used for solutes undergoing association or dissociation, as in depression of freezing point, elevation of boiling point? So simply multiply I here. Pi equal to ICRT. I equal to Van Graaff factor. We will further see how Van Graaff factor is calculated in the next class. धन्यवाद. फिर से मिलेंगे. सब्सक्राइब कीजिए, शेयर कीजिए. धन्यवाद.